Hello everyone, myself Netra, studying in Sri Venkateswara College of Engineering, Bangalore. Today in this video, let us discuss a topic, computer network development to achieve resource sharing, which comes under the topic computer networks. Introduction. The introduction explains the concepts and information of a computer network. A computer network is a group of independent computer systems connected to share resources such as software, data, and hardware. The goal is to allow any computer on the network to access these resources remotely, just like local users do, without any loss in performance. This could eliminate the need to recreate software and data at each computer center, which is currently costly and inefficient. The technology for creating such networks has existed since time sharing systems were developed, allowing multiple users to share resources on one system. However, connecting just two computers is not very useful as a larger network is more valuable. Challenges like slow communication lines, high cost, and inadequate technology have made it difficult to build large effective networks in past. Design of network communication service. After the Lincoln STC network experiments, it became clear that a new type of communication service what was needed for a useful resource sharing computer network. The existing communication systems were not enough. What was required was a reliable message service where computers could send messages to each other and ensure they were directly delivered correctly and quickly. Similar to how a user interacts with a computer, these messages often flow back and forth between computers, often in short bursts of 1 to 1000 characters. With many computers and users connected, the network could handle a large variety of conversations at peak times, leading to complex and diverse traffic. Reliability, responsiveness, capacity, and cost. Reliability means existing communication systems that have many errors and downtime for computer network. Line errors can be fixed with error detection and retransmission, but backup communication paths are essential to prevent total failures. Responsiveness, for a network to be effective for real-time use, the delay in sending messages must be minimal. Ideally, the round trip delay should be less than 1 to 2 seconds with quick delivery for interactive tasks like sending text or graphics. Capacity. Network capacity should scale with the number of nodes and users. In the experimental network of 20 nodes, traffic was expected to vary significantly, and the system must handle these fluctuations efficiently. Cost. Communication cost should be less than 25% of computing cost. The inefficiency of current communication methods contributes to high cost, often due to switching and operational costs. Various communication methods were evaluated with costs per million bits ranging widely, reducing the cost of switches and developing centralized network software would also cut down on expense and increasing reliability. To minimize error and downtime, the following steps were implemented: multiple transmission paths between nodes to prevent isolation, a 24-bit cyclic checksum for every 1000-bit block of data to detect errors, with retransmission in case of an error, reducing undetected error to about one per year across the network. The inference message processor IMPs were rigidized to withstand environmental condition and avoid using mechanical parts, improving reliability. IMP downtime is estimated at less time one failure per year, with a mean time to failure of 10,000 hours. Responsiveness. The goal for network responsiveness was to achieve a transmit time of 0.5 seconds or less for a 1000-bit message between any two nodes. Simulation showed that the transmit time was 0.1 second for a 1 kilobyte message, but only until the network reached saturation. After saturation, transmit times increases rapidly due to queuing delays. To avoid this, the network can temporarily limit input to reduce buffer use, which help to prevent long delays without significantly affecting overall performance. Capacity. The network capacity refers to the data throughput rate at which it becomes saturated. The saturation level depends on factors like network topology, system of capacity of the transmission lines, the distribution of traffic between nodes, and the average size of data blocks. A study by Network Analysis Corporation showed that the network's capacity can be increased by adding more transmission lines. Additionally, using higher speed communication service improves the network's cost performance and flexibility in handling larger data loads. Configuration. The initial configuration of the ARPA network is designed to support an average traffic of 16 kilobytes per node with communication circuit cost of $49,000 per node per year. If traffic increases, additional lines can be added to increase capacity. For example, to support 23 kb per node, the network can be expanded at an additional cost of $10,000 per node per year. This expansion process can continue until a capacity of about 60 kb per node is reached, at which the point of inference message processors (IMPS) would likely begin to saturate. Comparison with alternative network communication system designs. Next, in this slide, we can see the differences of cost versus delay for potential 20 nodes network design on the left hand side and effective bandwidth versus block size on the right hand side. Network plans. The ARPA network plans are divided into two phases: initial research and experimental use, and external research community use. In phase 1, which started in 1969 and should be completed by November 1970, 14 computer research sites were connected. Around 2,000 computer science researchers will use the network to share software resources and gain experience with different systems. In phase 2, which was started after November 1970, the network will expand to about 20 sites, including areas like behavioral science, climate dynamics, and seismology. This phase will focus on data sharing and the concepts of distributed databases. Conclusion. In conclusion, the development of computer network is essential for effective resource sharing. By connecting multiple systems through a network, organizations can easily access and share data, software, and computing power. This allows users to collaborate more efficiently, reduces the need for duplicate systems, and saves cost. As networks expand, they provide greater flexibility, improved access to valuable resources, and support for future technologies advancement. Ultimately, computer networks enables better communication and resources management across various fields and industries.